Okay, so we're going to take a look at a problem here where we're trying to use the normal model to compute the probabilities or percentages of trees that fall into certain categories in the forest. To start off, we're told that the average tree diameter in this particular forest is, let's read carefully here, 10.4 inches. So x bar equals 10.4. Standard deviation for these tree diameters is 4.7 inches. And the first part of the question says, go ahead and draw the normal model. So we're going to draw and label a normal model for the trees in this forest. So I'm going to start off by drawing a normal model. There it is. Average tree diameter, 10.4. Standard deviation is 4.7. So we need to move over. We know from the empirical rule that 99.7% of all values on the normal curve are within 3 standard deviations of the mean. So there's really no reason for us to label any farther than 3 standard deviations from the mean. So I'm just going to mark off 1, 2, and 3 standard deviations below and 1, 2, and 3 above. To help me get started, one way to try and eyeball what one standard deviation is, if you're looking at your normal curve, if you see that at the beginning of the curve, coming off the center, off the mean, it's concave down or bowl-shaped down, and then all of a sudden it switches to being bowl-shaped upward. At that switch point, that's one standard deviation from the mean. So it's called a point of inflection. So we're going to move one standard deviation in both directions, and then I'll just measure off, use that as kind of a ruler. 2 standard deviations will be about that far, and 3 standard deviations will be about that far. And it doesn't have to be perfect. It's just, the more you draw them, the better you get, although you can see that I'm apparently not that great at it yet. So I'm just going to move 4.7 in both directions. 10.4, I'm going to grab my calculator here, 10.4 plus 4.7 is 15.1. So this value, 1 standard deviations above the mean, is 15.1. 2 standard deviations above the mean is 19.8. And 3 standard deviations above the mean is 24.5. If we did the same thing going downward, 10.4 minus 4.7 is, some of you are probably doing this in your head already, is 5.7. If I subtract off 4.7 again, we've got 1. And if I subtract off 4.7 again, we actually get negative 3.7. Now you might be saying to yourself, Mr. Burkholder, we can't have negative tree trunk diameters, and that's true. We're not going to be too concerned about that because we know that 95% of all data values are within 2 standard deviations from the mean. So there aren't too many values that are going to be below 1, and in this case, any values that are below 1 would have to actually be greater than 0. So we're not going to get too worked up about it. But there's a look at our normal model. We can now go ahead and add in the empirical rule and kind of show what that tells us. We know that 68% of our data values are going to be between 5.7 and 15.1. We know that 95% of our values are going to be between 19.8 and 1 inch. And we know that nearly all, but let's call it 99.7% roughly, 99.7% of our values will be within 3 standard deviations, and in this case that's more than 0 and less than 24.5. Now we can use this new diagram to help us answer the next couple of questions. What size will we expect the central 95% of trees to be? Well, we've actually already identified that, so let me just highlight that for us. I'm going to use green for trees. The central 95% we expect to be between 1 inch and 19.8 inches in diameter. For letter C, about what percent of trees should be less than 1 inch? Well, this one's a little bit more difficult to answer. If we want to look at what percent are less than 1 inch, we're trying to find this area under the normal curve that's down here. Between 1 and, well, negative 3.7, but we really know that it's between 1 and 0. Well, we know that 95% are within 1 and 19.8. So 95% are there, which leaves us with 5% out here on the ends of the graph, out there above 19.8 and below 1. Well, because the normal curve is symmetric, we know that each one of these little shaded regions actually represents 2.5%. So 2.5% are more than 19.8 inches in diameter, and approximately 2.5% are less than 1 inch in diameter. So the answer to the question C, what percent of trees should be less than an inch in diameter? We would have to say around 2.5%. What percent of trees should be between 5.7 and 10.4 inches? Let's switch colors again, and we'll jump to this nice purple color. So between 5.7 and 10.4. Well, let's go back up here and look at our labels. 68% are between 5.7 and 15.1. Again, symmetric curve. That leaves us with roughly 34% in this region and 34% in this region. So to answer question D about what percent of trees should be between 5.7 and 10.4 inches in diameter, we would say roughly 34%. Now our last question is a little bit more difficult. What percent of trees should be over 15 inches? Well, if it said over 15.1, we could use a similar process just by breaking down the empirical rule. But it doesn't say 15.1, it says 15. So the first thing we're going to do is we're going to compute the z-score for the data value 15 inches in diameter. So that z-score is going to be 15 minus 10.4 minus the mean divided by the standard deviation divided by 4.7. So if I grab my calculator and take 15 minus 10.4, and again I apologize, I can't do this on the screen with you right now because I would lose all my annotations. You'll see in just a second. And then, so that's 4.6 divided by 4.7, and we're just a little bit less than 1 standard deviation from the mean. We're about 0.98 standard deviations from the mean. Well, our question is, there's our mean, 0 standard deviations from the mean would be the mean. We want to move over here just about 1 standard deviation, about 0.98 standard deviations from the mean. And the question is, what percent of values, or what percent of trees have a diameter that's more than 0.98 standard deviations from the mean? So we're looking for that shaded region. Now, to calculate that value, what we need to do is we need to use the normalcdf command on our calculator. So that area right there, to find that area, we're going to compute normalcdf, and with normalcdf you simply input the 2 standard deviations that you're trying to find the area between. We want to find the area between 0.98 standard deviations and infinity standard deviations, because we actually know that this normal model it does actually continue up here indefinitely. Then these values get so much smaller that, or the percentages are so small when you get far enough beyond a few standard deviations from the mean that they're almost negligible. So how do we handle that, or how do we handle infinity on our calculators? Well, we're going to just say normalcdf from 0.98 standard deviations, and we're just going to go all the way up to 99, because really anything beyond that, or actually we could probably just go up to about 10 and it would be fine. But the percentage of values that are up beyond 99 standard deviations from the mean are so tiny, or the percentage is so tiny that we don't have to worry about it creating any error in our calculation. So now I'm going to show you how to use your graphing calculator to compute that value. We're going to lose our annotations here when I switch to the calculator, but we want to type in normalcdf from 0.98 to 99 standard deviations. So here we go. Say goodbye to our annotations. Let's switch over to the calculator. To get to the normalcdf, we want to go into the distribution menu, which we can see is found in the vars button, and that is right here. So we hit second, then vars, and now we're going to go ahead and choose the normalcdf command, which is the second option. So you can either press 2 or press the down arrow, either one. And for some reason I can't press the down arrow. There we go. I'll just hit 2. And then we're going to do 0.98. then the comma button, which is right above the 7, and then we're going to go all the way up to 99, and that's how we say forever. If we wanted to know between 0.98 and, say, 2.5 standard deviations, I just go 0.98 and 2.5. But because we want to go forever to the right on our normal model, we're going to go ahead and just enter in 99 there. And we're going to calculate. And we can see that roughly 16.4% of trees are expected to have diameters that are 0.98 standard deviations from the mean or higher, or in this case that really just means about 15 inches in diameter or more. So hopefully this video helps you understand how to compute normal probabilities and also how to use the normalcdf command on your calculator.